A warm welcome to today's online session about the topic complete machining of complex workpieces from the aerospace industry. My name is Andreas Lehner and I'm sales manager at WFL Millturn Technologies. Today we will explore the following topics. At the beginning I will introduce WFL Millturn and our machines. Then I will give an introduction about the segment aerospace industry and what WFL considers as aerospace industry. We will look at a customer case study about the jet engine shaft. Then we will have a look at the necessary Millturn features, not only the mechanical features, but also software features that are needed to machine such kind of aerospace parts. At the end of the presentation, we will have a look at the different kind of measuring technologies that are applied at the WFL Millturn. At the very end of the session, it is possible to ask questions. Please use the chat functions, and I will read the questions from the chat function. WFL Millturn Technologies is situated at Linz in Upper Austria. At this location, we are about 450 employees. We are focusing on machining solutions on machines for complete machining of complex workpieces. About 40 years ago, WFL developed the first machining center worldwide, which was quite unique at this time. And since this time, we continuously develop new machines, new technology solutions. It's not only about the machine, but we are offering turnkey solutions, including the machining process, including tooling solutions, software solution, training, and so on. On this slide, you can see an overview of our product range. The smallest machine, the newest, latest model is our M20 Millturn with maximum turning diameter of 500 millimeters and maximum workpiece length of 1 meter. The largest model is our M200 with up to 2 meters of turning diameter, up to 14 meters of length for very large aerospace components, for example, as very large landing gears and so on. All these machines have in common that you get the full technology package from WFL Millturn for machining difficult aerospace components. We are concentrated on complete machining. On the left side, you can see the classical machining process, the old machining process, using several machines for one product. So you're forwarding one product from one machine to another, for example, from a boring machine to a milling machine to a turning machine. Every time you have to set up the part. You have different kind of NC programs, some very often different kind of controls. Yeah, this takes more lead time. It is very likely to have more scrap in this classical machining process. You have also cost for warehouse cost of these parts. The parts have to be stored between the machine, so it's very cost a process, very high costs. On the right side, you find the WFL Millturn complete machining process, only using one machine, so you have only one program set up one time. Is less scrap, higher quality, and also shorter lead time, decreased costs, and higher part quality. That is what WFL Millturn stands for. On this picture, we see an example of a large landing gear component made from titanium. It's clamped on the left side in a 3-jaw chuck. It's supported at the bottom system by a steady rest. And you can see in this illustration, this is a boring bar for ID machining of such components. Which kind of technologies can be applied on the WFL Millturns? For aerospace components, many different kinds of technologies are needed. The core technologies are turning, boring, milling. Very important part is in-process measuring, which I will give more details later on. You can do different kind of gear cutting technologies, not only mechanical solutions, but we also provide you with the software solutions for programming gear machining. You can use different kinds of ID machining tools, for example, large angular heads, bottle boring tools, damped boring bars. Our Millturns are fully 5-axis machining centers. Other technologies which can be applied, for example, ultrasonic measurements, grinding, deep hole drilling, and so on. So you can use a very wide range of different kind of technologies which are needed for complete machining. So which kind of segments do we consider as aerospace when we talk about aerospace industry? The first is fixed wing aircraft, so all components that are needed for aircrafts. The second is rotary wing aircraft, so it's basically helicopter components. On the third segment is spacecrafts, is for rockets. Some exemplary parts are, for example, flat lever for the fixed wing aircraft, different kind of landing gears. Here we can see a very large landing gear. It's up to 2 meters. Different kind of turbine shafts, so components for the engine of the aircraft or stub shafts. These parts have in common, they're very complex. Material is very difficult to machine, and you need a lot of different kind of technologies. Exemplary parts for rotary wing aircraft, for helicopters, for example, are landing gear as well, then tail rotor shaft, the rotor star, and the rear rotor shaft. Very often titanium is used as material of these components. And the third segment is for spacecrafts, different kind of components, fuel pump housings, tip, for example, turbopump shafts, combustion chamber. All these parts are machined on a WFL Millturn. Now we will have a look at our customer case study. On the left side, you have some exemplary illustration. So before this process was put on a WF Millturn, it was done on different kind of machines, boring machines, milling machines, turning machines. Very typical materials in the aerospace industry are titanium, nickel-based alloys, cobalt-based alloys. Inconel is very common, the name, pH 250, Aeromet, Super CMV. The goal of the WFL process optimizations is always to decrease the lead time, therefore also decrease the costs, but always having good, very good part quality or an even better part quality as the process before. We are using this jet engine shaft, which is machined at a WFL Millturn. The part is machined in soft conditions at about 300 HP and is well finished machined in hard conditions about 50 HRC. So the part comes pre-turned at the WFL Millturn, about 2 mm stock per side. We do the ID machining of the parts, we do the outside machining, do a thread machining at the end of the parts, gear machining, milling all the slots and keyholes. On the very bottom, you see the drawing of the part. We also do the ID machining with this difficult bottle shape inside of the part. Here we have an overview about the process, how it was before the WFL Millturns. The process was split, it was separated on different machines, drilling machines, milling machines, turning machines, which you see at the left upper diagram. The machining time and the setup time was quite balanced. It was half-half. Half was already of the total lead time was the setup time. And also the time between roughing of the part as well as finishing on the parts was quite balanced in this case. Here we see the total process steps, the OPs for this customer part from OP5 to OP275. On the left side, you have the existing process, the old process the customer had applied. On the right side is the new process. we decreased the operations. So on the middle, you see the Millturn, but still the frozen process. On the very right, you see the new process, which WFL optimized, reducing the operations and the machining time. At the end, we could decrease with our WFL complete machining process the setup time about 90%, the machining time about 70%, the manual interaction time we could decrease about 20%, and the total lead time for this jet engine shaft was decreased about 70%. At even a much better part quality in this situation. So less lead time, decreased cost, better quality. That's WFL philosophy. Well, now we will have a look at the features which are needed to machine such kind of parts. First is our WFL is very unique on the market, is the prismatic tool solution, the prismatic tool accommodation. The WFL Millturns have a unique interface for mounting large and heavy tools. So the tools are very rigidly clamped on the turning boring milling unit, which allows to use very heavy tools, as well as allows to do machining without any vibrations using very long boring bars. Tools that are used, for example, are CNC special contour boring bars. Boring bars for ID machining are large angular heads for inside machining. We are also using CNC facing heads with additional U-axis for conical inside or outside forms. In addition, these tools can be mounted or automatically changed from the magazine. There's a special tool magazine, so this is a total automatic process using this kind of tools. The next feature, which is very helpful, gives a big benefit for this kind of part, is the ultra high pressure coolant. The ultra high pressure coolant gives you the benefits, the advantages of better chip control. So high pressure coolants, about 300 bars, you get smaller chips. It's a higher process reliability because of the better chip break. There are less manual intervention, for example, for cleaning the chips or to clean the chips accumulations in the part. You have an extended tool life applying high pressure coolant, which is also very cost effective. And it reduces machining time due to the fact that you can apply different better cutting values, better cutting parameters to the parts. You can see on this slide, we made internal tests and developments for this high pressure coolant. You can see the chips at 10 bar, the chips result at 80 bar, and the chips at applying 300 bar during machining. And you have considerably smaller chips at 300 bar, also for different challenging material. And therefore you have all these advantages. Up to 200 bar, we can directly put through the milling spindle, through the tool, applying at the workpiece. It's not only mechanical solutions which you need for such kind of parts, but also software solutions. This is an overview of the WFL software solutions. On the left side, you can see our software solution, Millturn Pro, CrashGuard Studio, and our WFL software cycles. This is the software solution for programming and C programming, as well as simulation of the NC program. We are offering a lot of different kind of WFL software cycles, what we call it. And so it's easy programming by using parameters. In addition, we have our CrashGuard, which is the online live collision protection software. We have the iControl, which is the process monitoring software solution. And for example, also WFL remote support, which is a very important integrated part of our service solution. WFL is very well known for fast and quick service, for very professional service. And that's very important for the reliability of the machine. Now we will have a look at few of these software solutions. The first is the crash guard. It's our online collision prevention. It's live. So when the NC program is already running on the machine, it avoids collisions between the machine components, between the clamping devices, as well as the workpiece. So it prevents collisions due to maybe wrong programming, wrong NC programming, or wrong setup of the tools. Therefore, it avoids costs for repair as well as downtime. Now we'll talk about iControl Advanced. It's our process monitoring software. With this iControl Advanced, the software can detect tool breakage, it can detect tool wear, calculate tool wear, and avoids overload of the machine axis. Now we have an example of a landing gear. So when we do ID turning at the landing gear with the boring bar at the very bottom in the illustration, the first few millimeters, the machine automatically learns the nominal force, which is the normal force, and automatically monitors the rest of the distance. So it automatically detects the nominal force. In this case, we said plus minus 10% of the force is okay. You have no problems. Everything out of this range is an issue. It could be that you have too much tool wear. Then it automatically changes, for example, it's the assisted tool that processes the machine. In case the insert, for example, is broken, the tool comes out of the part and goes to a safety position, for example. Therefore, this process monitoring increases process reliability. The next very important topic is measuring technologies. Especially in the aerospace industry, the parts are very complex. The raw part is already very expensive. So WFL has to make sure that the first part is a good part, and that's our philosophy. We have different kind of measuring technologies. One is the standard measuring probe, which is changed from the tool magazine. The next one is scanning measuring probe, the in-process measuring, and the ultrasonic measuring. We'll have a look at each of these technologies. The first is the standard 2-point measuring technology. Therefore, we are using a radio probe from the tool magazine is automatically exchanged in the turning point milling unit, and we can measure the work pieces very accurate. For example, for the finish machining, we do the measurement, we make a test cut, then you do the second measurement, and automatically putting the tool correction into a tool management, and the tool correction is already considered for the final cut. The next solution, WFL solution, is the integrated workpiece measurement probe. A probe is directly mounted on the turning point milling unit, is swiveled in when it's needed. And the advantage is it's a very accurate probe, as well as that you have no lead time for exchanging the probe out of the magazine into the TBM unit. And also you have no error when exchanging the tool in the TBM unit and back. So therefore, this accurate probe is used, for example, when you have very tight tolerances, you have to reach, for example, IT5 and similar tolerances. We recommend you this kind of solution. The next one is the scanning probe. So this is a probe that is scanning the part. Here, for example, scanning the part. You can measure the roundness and the run out of the part automatically, as well as the surface quality, RA, RZ values, and so on. The know-how is in the software. It's our WFL software and user interface and algorithm. So it's easy to use, easy to program, and you can measure the run out, roundness, and so on. The big advantage is that the part is still clamped is still in the machine, and you can do the correction automatically within the next machining steps. Another measurement technology is the ultrasonic measurement. We can do ultrasonic, totally fully automated ultrasonic measurement, wall thickness measurement within the machine. As a coupling liquid, we are using our coolant. There's no coupling gel required. And we also have our user interface, easy to use for this solution as well. Therefore, we can adjust the outer diameter to the inner bore of the workpiece. For example, it's used for jet engine shafts and to make the very tight, to reach the very tight tolerances. And is a fully automated process. Good. At the very end, I will give you I want to show some references. So these are companies that use WFL Millturns, some of them already some decades, very successfully. For example, Airbus, Boeing, MTU, Ariane Group, for example, for rockets or spacecrafts, Airbus helicopters for helicopters, or companies such as Pratt & Whitney for jet engines. He appreciate the solution of the WFL Millturns. Here you can find my contact details. In case you have any questions in the following days, don't hesitate to write me an email or to give me a call. I'm happy to consult you on your machining demands for the aerospace components. Now we are at the end of the presentation. I thank you for participating. It was a pleasure to give you the information on our solutions. And in case you have any questions right now, please use the chat function. I will now open my chat function. In case you can put some questions in the chat. I will wait a few minutes. Otherwise, I will thank you for participation and wish you a good day. Thank you. Good. In case there are no questions, thank you for participating. Goodbye.